Okay guys, let's find the last digit of 7 raised to the power of 3, raised to the power of 9999. Okay, look at this number. This is a very large number and don't use a calculator. Alright, so let's try to do this problem. I want to start with 7 to the 1, which is 7. 7 square, 49. 7 to the power of 3. Okay, what is this number? 7 to the power of 3, 343. Okay, 7 to the 4 is 7 times this one is this one plus this one and this one. So it turns out to be 2401. Okay, 2401. I want you guys to look at the last digit of these four numbers. We have 7, 9, 3, and 1. Okay, so we think the next one we have the last digit as 7, right? Because if you multiply by 7, the last digit becomes 7. Okay, 7 to the 5 becomes, okay, let me think about this one. So for this one, okay, 28 and 7. Okay, 26807. 16807, and go back to the last digit with 9, right? Okay, 7 to the 6 has last digit of 9. Okay, 7 to the 7, it has last digit of 3, and go back to 1 and so on, right? Okay, has the last digit of, okay, this one is 3, this one is 1, 3 and 1. Okay, 7, 9, 3 and 1, 7, 9, 3 and 1, 7, 9, 3 and 1, and 7, 9, 3 and 1. Okay, every four number, okay, how do I say it? It's going to have this loop, okay, for every 4, exponent of 4. So I have to look at the exponent, okay, that has the multiple of 4. So I want to consider 7 to the power of 4n, where n is any integer, okay, for any integer n. Alright, so we use binomial, okay, so binomial expansion, so what I want you to do is to try to have the value of n right here. Okay, so what we want to use the binomial expansion, so we gotta have 7 to the 4 n, which is 7 to the 4 raised to the power of n, and 7 to the 4 is this one, 2401, so it turns out to be 2401 like this, raised to the n, which is 1 plus 2400 raised to the power of n, and the binomial expansion turns out to be r, start from 0 to n choose r, 1 to the power of n minus r, 2400 raised to the power of r, and expand it. So we gotta have n choose 0, okay, 1 to the n minus 0, 2400 0 plus n choose 1, so we're gonna have n to the n raised to the power of n minus 1, 2400 raised to the 1, right? Plus n choose 2, 1 raised to the power of n minus 2, n to the 2, and the third one. Okay, and the third one, n choose 3, 4000 raised to the power of 3, and so on. Don't forget that we have to take a look at the last 3 digits. This means that we don't have to calculate 7 raised to the power of 9,999. So let's deal with these terms. Okay, so do not forget that n choose r. Okay, this is n choose r. This is n factorial over r factorial n minus r factorial. Okay, this is the number of, this is combination. Okay, combination, in which we learn in combinatoric. Okay, it's going to be this factorial, fraction of this factorial. So n choose 0. What is this number? N choose 0 is n factorial over 0 factorial, n minus 0 factorial. Let me copy to here. And 1 to the n, 2400 is 1. N choose 1 is n factorial over 1 factorial, n minus 1 factorial times 1 to the n minus 1, and 2400 plus n factorial over 2 factorial, n minus 2 factorial, and 1 to the n minus 2, 2400 square. Alright, and n choose 3 is n factorial over 3 factorial, n minus 3 factorial, n to the 1 minus 3, 2400. Okay, this is 1. This is 1. This is 1. This is 1. This is cube. Okay, what is this one? Okay, let me try to calculate 24 times 24, which is, okay, this one, 16 is 6, is 576. So we're gonna have, okay, the first one is 1 plus n factorial. Actually it is n times n minus 1 factorial. So n factorial will be cancelled. Okay, and this n factorial becomes n times n minus 1, n minus 2 factorial is n minus 2 factorial, cancel, and n factorial is n times n minus 1, n minus 2, n minus 3 factorial. Okay, these will be cancelled. So what we have right here is going to be 1 plus n. Okay, n times 2400 is 2400n plus, next term is 2000 square, 2400 square times n factorial over n times n minus 1 factorial. This one here over 2 factorial, which is 2 times 1, plus this one here, we have n factorial over, okay, so 2400 cube n times n minus 1 minus 2, okay, n minus 2 over 3 factorial is 3 times 2 times 1, and so on. Since we want to just look at the last 3 terms, so we don't have to expand all this. But this one, this is the third term of the expansion. Okay, so we look at the third term. So the third term of the expansion is this one. So we will have 24 square, 10 to the 4, okay? 10 to the 4. And divided by 2 times 1, n times n minus 1. So it's become 12 times 24 times 1,000, okay? Oh no, 10,000. And n times n minus 1. What does it mean by this? This means that from the third term, there will be 4 zeros, okay? 4 0 on the last 4 terms. This means that from the third term, the fourth term, and so on, doesn't affect, okay? Did not affect the last 3 terms of 7 raised to the power of 999. Okay, so we will just look at these 2 terms, okay? These 2 terms here. All right, okay, got it. So now, so we have to consider this one, especially the second term. Now, so we have to consider the first and the second term, okay? Especially 1 plus 2,100 and n, okay? You have to consider to have last 3 terms of 7 raised to the power of 999. Okay, so let's get started. So we're gonna have 7 raised to the 999, in which become, unfortunately, 9,999 is not divisible by 4, so I gotta write 79996 plus 3. So we're gonna have 79996 times 7 raised to the power of 3. So it turns it to be 7 is 4 times 2,499 times 7 raised to the power of 3. Okay, and I will substitute this one 2,499 into here, here, and here. All right, so we gotta have 1 plus 2,400, 2,499, okay, plus this one is interesting, okay, plus what? Plus, okay, let's start to plug in this one. Okay, so this one becomes 2,499, 2,498 divided by 2, plus and so on, and multiply 7 raised to the power of 3. 7 to the 3 is 343. Okay, 343. And all of these terms do not affect last 3 terms we want to find, right? So now, we just consider this term. Okay. So, we need one more page. So, we will observe. Do you observe this one? The last 3, the first 2 terms. So, we gotta have 1 plus 4,000, 2,400, 2,499 times give me a second, times 343. All right, and distribute 343, we gotta have 343 plus 22400 and 1500 minus 1. Okay, and 343. All right, now the number is not difficult. Okay, we have 343, and we know that 24 times 25 is 600, so we're gonna have 600 and add 1 2 3 4. Okay, and minus this one, right? 3 4 3. Okay, and then what do we have here? We gotta have 3 4. Okay, 343 plus, okay, let's subtract this number. So we gotta have what do we have here? So we gotta have what am I doing here? So I want to subtract this one, but I cannot figure it out. Okay, it's 5999. Okay, not 9, 7 600. Okay, and 343. All right, and this is 343. So we gotta have 5,997,601 and 343. It seems that the last three term is what? Okay. So if you multiply by 3 to the last three terms of this, so we're gonna have 183, right? Multiply by 4 with this is affect the first, these two terms here. Okay. If you multiply by 3, we're gonna have number 8 right here. So we're just interested in the last three terms of this number. Okay, so I gotta write dot right here, 601 343. Okay, and let's multiply. So we're gonna have 599,7,601 343. Multiply by 3, we're gonna have 3081. Okay, right? That's it. And 4 times 1, so we're gonna have 40 like this, and 3081, we're gonna have 3 4 and 1 like this. So the last three terms becomes, it's going to be dot 1 4 3. All right, so therefore the last three digits of what? 7 raised to the power of 999 is going to be 143. Okay, it turns to be 143. All right, that's it for today, guys. Okay, and see you in the next video.